let's look at another example here where we have, I'm given some initial information that I've already kind of written down a little bit. I'm given that I have an angle that's in the second quadrant, and that the sine of this angle, sine of alpha, is 12/13. And given that information, I went ahead and drew what that angle looked like, an angle in the second quadrant. Its sine, which was its opposite over its hypotenuse, was 12/13. So opposite is 12 over 13 is that information. Likewise, I was given another angle beta in the first quadrant whose sine was 3/5. And I drew that down where its opposite, if I drew a right triangle, its opposite was 3/5 or 3/5. So given that initial information, I want to find the cosine of alpha plus beta, and I want to find the sine of alpha plus beta. So how do I go about doing that? Well, first of all, since both of these involve the cosines of alpha and beta, I need to find out what those are. And the best way to find those, for me at least, is to fill in the rest of the right triangle information that I have. And so if I remember, the cosine was the x value associated with this point, and the sine was the y value associated with that point. The x value at this point, this distance right here, is, well, if I recognize it being a 5, 12, 13 triangle, which is something we're picking on up. If not, I remember that this side, which is some x squared, plus this side equals the hypotenuse squared. And so this becomes x squared plus 144 equals 169, x squared equals 25, x equals plus or minus 5. And so this distance is 5. Since I know it's in the second quadrant, it has a value of -5. Likewise, if I wanted to find this value of this leg over here, I can do the same thing, and I'll discover that that's a 4. Now, why is that helpful for me? Well, it's helpful now that if I wanted to find the cosine of beta over here, so let's say, let's just write over here, the cosine of beta. Well, beta or cosine was adjacent over hypotenuse, so adjacent was 4 over a 5. So I know cosine of beta is 4 over 5, and the cosine of alpha is likewise, it's the adjacent, which in this case is a -5 over the hypotenuse, which is a -5 over a 13. And so now I have all the information I need. I have cosine of beta. Let's write down the sine of beta, which was already given. The sine of beta was 3/5. And the cosine of beta, cosine of beta, I have the sine of alpha, sorry. The sine of alpha, that was also given already as 12/13. So now I have the sine and cosine of all the angles I have, so I can go ahead and use this cosine of the addition of two angles. So the cosine of alpha plus beta equals the cosine of alpha plus the cosine of beta minus the sine of alpha and the sine of beta. So the cosine of alpha, the cosine of alpha is -5/13. And actually, I don't need to put the cosine of alpha. The entire cosine of alpha is -5/13. The cosine of beta is the entire 4/5 minus the sine of alpha, which is 12/13. And the sine of beta is 3/5. So let's go ahead and multiply those on up. That's -20 over 13 times 5. 5 add the 1, 65. Minus 36 all over 65. and that equals a minus 56 over 65. So there's a cosine, their value of cosine of alpha plus beta. Now let's look at the sine of alpha plus beta. So the sine of alpha plus the sine of beta equals the sine of alpha, cosine of beta, plus cosine of alpha, sine of beta. I know the values. Sorry. I should have wrote this as like this. There you go. All right, so the sine of alpha, we already know. We know that its value is 12/13. The cosine of beta, we discover is 4/5. The cosine of alpha is minus 5/13. And the sine of beta is 3/5. So 12 times a 4 is a 48 all over 65, which I worked out earlier, plus a negative 15 minus 15 all over 65, and that equals 33 over 65. So there I went ahead and found the summation of both the cosine of those angles and the sine of those two angles.